All right, this is my lesson for 6.8. Oh, not B, A. All right, so now we are into natural logarithms. It's essentially the same standard that we've been working with, connection between exponential and logarithmic functions, um, simplify logs, whether they're common or natural logs. I can use those properties to rewrite them in different forms. I know and can use the change of base formula. We learned that last lesson, and I can solve exponential equations and inequalities. I can also solve logarithmic equations and inequalities. Okay. All right. The natural logarithm has a base of e, which is approximately 2.7182818, and so forth. It goes on forever and can be written as the ln of x, which is log natural of x. It has a base e, which is implied and not written. You can find it on your calculator to the left of your 4 key if you have a TI-84. So let's go ahead. And basically where this came from is that we have a lot of actual natural data that is in nature that follows the this model, and that is why we have a base of E. Okay. All right, so evaluate the following expressions with your calculator. So we're just going to plug in um, the ln using your calculator of 5 and hit enter so we can kind of get a practice on that. And we get approximately 1.609. And then you can try one on your own. So type in natural log of 20, which gives me 2.996. Okay, now we are going to essentially, this is going to almost be a review in my opinion, this lesson. We have had this before, and now we're just using natural logs. So remember that the output of a log is an exponent. That's something to remember. Okay, we're going to rewrite these logarithmic equations in exponential form. We have the natural log of 8 is equal to 2.0794, and we want to rewrite this in exponential form. Well, this is base of E, and so we're going to rewrite it in exponential form. So the base is E. The output of a logarithmic function is an exponent. So that is 2.0794, and it equals 8. So when we take the natural log of 8, we're asking e to what power is equal to 8, and that is approximately 2.0794. Okay, the next problem, remember, it's implied that since it's natural log that it is base e, and so the base stays the same. E to what power? Remember, the output of a log is a exponent, so we'll put that 12 where it belongs, and essentially it writes e to what power is equal to x, and they gave us 12, so e to the 12th power is equal to x. And so we have rewritten this in exponential form. All right, why don't you try one yourself? Welcome back. So the base is e, the exponent is the x, which was the output of my log, and the answer is 5. So e to the x power is equal to 5, and we have rewritten that log in exponential form. Now we're going to go the other way. Rewrite the exponential equation in logarithmic form. Now I know that the base is e, so I have the ln of base e, which I don't have to write, that is implied. And notice that it has a value, an output of well, actually, let's remember that the output of a log is my exponent. So here is my exponent. And so the answer is 5. And so my input is 148.4132. So it's asking the question, e to what power is equal to 148.4132, and it's to the 5th power based on what they gave me. And let me make that a little bit clearer. Okay. The B, e to the x equals 13. How do I write that in log form? So it's the natural log. The output of a log is an exponent. So we have x is my exponent, and we will say natural log of 13 is equal to x. Okay, why don't you try one yourself? Welcome back. Again, the output of an exponent is, a log is the exponent. And so the output is going to be 3. The base is e, and my input will be x. E to what power is equal to x? That's how you would read that. All right, simplify the expression. Okay, so we are going to simplify using our properties of logarithms. And even though it's natural log, they're the same property. So in the first one, A, I have 3 times the natural log of 10 minus the natural log of 8. I notice that I have a 3 out here, which is a coefficient. I can make that a power minus 8. Now I have a subtraction, and I can combine those using division, and I will have 10 to the third over 8. So I'm taking the natural log of all of that. My numerator is my positive, and my denominator was my negative. And now I'm going to simplify that even further. That will become the natural log of 1,000 over 8. And I will simplify that one step further. 1,000 divided by 8 is 125. And you might box this, and that would be perfectly acceptable. However, I want to point out a couple things. Your book will give you this answer. So the natural log of 125 can be written as 5 cubed, and I can then take it another step further, and I would write 3 times ln of 5. Okay, and so they're going to minimize the value that's in the natural log. Okay, and they will write it in that way. For our purposes, this is an acceptable value, ln of 125. In a lot of multiple choice questions, they will take it a step further, so be aware of that. B, these are all addition. I have addition, I have addition. So I'm going to combine all of my additions with multiplication. Okay, so I'm going to rewrite this all in one step. Log of 40 times 1/2 squared times x. So where did I get all this? So here's my 40, and then I'm going to multiply it times 1/2 to the 2 power. Where did that come from? That came from the coefficient out front. And then I have multiply times x. Okay, so I can simplify that even further. The natural log of 1/2 squared is 1/4. So I have 40 over 4 times x, and that will equal the log of 10 times x. And that will be my answer. I hope that makes sense. All right, try one yourself. All right, welcome back. So we have 3 times the natural log of 8 minus 2 times the natural log of 4. I can combine those. First, I'll do it in steps. 8 cubed minus ln of 4 squared. And then I'm going to combine them because I have subtraction, so I can use division. So I have ln of 8 cubed divided by 4 squared. That's all my input to my log. I am going to then simplify that. Come on. Oh, come on. Equals, there we go. ln of, well, it's the same as 8 times 8 times 8. That is what 8 cubed is. 4 times 4. I can do some simplification, can I not? I have this will go away, and that becomes 2, and that will go away. So I have 2 times 2 times 8 still left in my denominator, and I get natural log of 32. And this is actually what I did when I did it or completed this problem. But then it has been brought to my attention that the book will take it even a step further. Natural 32 is the same as 2 to the 5th power. And we can take that 5 and bring it in the front, and we have 5 times the natural log of 2. Both of these are correct. This is going to be what the book has. This is also acceptable on your test. but they're simplifying it to the smallest value in the natural log. Okay. All right, your turn. D, welcome back. Try, I'm going to combine this. I have an addition. Okay, so I can do multiplication. Plus I have some coefficients that I can raise. I can put that as an exponent. I can put that as an exponent. So here we go. I have log of 2 to the 6th power over a 4th to the squared. Okay. No, I'm sorry. They're addition, not subtraction. So let's try it one more time. I can combine using multiplication. Apologize. So I have log of 6, no, 2 to the 6th power, 2 to the 6th power, multiplied times a 4th squared. Okay. So let's kind of, I personally plug that into my calculator, but we could see what that looks like. I have 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6. And I also have 2 fourths times each other. So that's what that looks like. I can get rid of 2 2s and 1/4, 2 2s and 1/4, and I'm left with natural log of 4. And this would be a perfectly acceptable answer. However, what's the book going to give you? Log of 2 squared is the same as a 4th, which will be equal to 2 times natural log of 2. All right. Hope that makes sense. Okay, here we go. We are to solve the logarithmic or exponential equation. So I need to find the value of x that makes this equation true. I have on the left-hand side e to the negative 2x that I want to get by itself. And so I'm going to start by adding 5 to both sides of the equation, and I get 4 to the e to the negative 2x equals 8. Now I am going to undo the multiplication of 4 by dividing both sides by 4, and I get e to the negative 2x is equal to 2. Now, how do I undo an exponential expression? I take the log, and since this is e, I'm going to take the natural log. So I will take the natural log of both sides of the equation. Now I have undone my exponent, and I get negative 2x is equal to the natural log of 2. I can then undo the negative 2 by dividing by negative 2. Same thing as multiplying by negative 1/2. So I get x equals negative 1/2 times ln of 2. All right, now let's talk about this for just a minute. This can also look like x equals a negative ln of 2 over 2, which is what you would have got if you divided by negative 2. And the question is, why do we have this 1/2 out in front? Well, the reason is a lot of times students don't do a very good job of making sure that this division symbol is very clear that we are dividing the entire natural log of 2 and not something like this. And that is now very potentially misleading and could be incorrect. Okay, so be very careful to ensure that you are crystal clear about what's being divided, not just the 2 divided by 2, but the entire natural log of 2, or better yet, pull your fraction out so we know we're multiplying that by 1/2. Okay, hope that makes sense. Okay, your turn. Welcome back. I'm going to undo this multiplication of negative 2 by dividing by negative 2 on both sides. And I get e to the x plus 1 is equal to 9. How do I undo an exponent? I'm going to take the log. Well, it's a natural log because I have a power e. So I will take the natural log of both sides. And I will get x plus 1 is equal to the natural log of 9. I have to undo the addition of 1, and I get x equals ln of 9 minus 1. All right, let's do the next one. On the next problem, I find that I'm going to subtract 10 from both sides. I get ln of x squared is equal to a positive 6. How do I undo a natural log? Well, I can raise it to the e power. So everything on the left, e to that power, everything on the right, e to that power. That undoes my natural log, and I will have x squared on the left-hand side and e to the 6th on the right-hand side. How do I undo x squared? I take the square root. That is the same as taking it to the half power, and hopefully you'll see why I think of it that way in just a second. So on the left-hand side, I get x, and on the right-hand side, I have e to the 6th to the 1/2 power, and I'm going to multiply that 6 by 1/2, and I'm going to get e to the 3rd, but it will be a plus or minus. So when I take the square root, it is plus or minus. And so this is my answer. A little bit tricky on the plus minus, I understand. So, but we can there's a couple different ways to think about it. When we take square roots, we're asking ourselves what number multiplied times itself gives us that value. I can have both a positive or a negative. Okay, D, let's see if you get the right answer. Welcome back. First thing I need to do is undo this multiplication of 8 by dividing 8 out from both sides. I get ln of x plus 1 is equal to 40 divided by 8, which is the same as 5. Now, how do I undo a natural log? Well, I take that entire left-hand side, I raise e to that power, the same with the right-hand side. I have essentially undone the natural log. So now I have x plus 1 is equal to e to the 5th power. Okay, I need to undo the addition of 1 from both sides, so I subtract 1 and I get e to the 5th minus 1. Okay, all right, e. I have the natural log of 2x minus 3 to the 3rd power equals 6. I want to undo the left-hand side, or the natural log, so I'm going to take everything e to that power on both sides of the equation, and on the right-hand side, or sorry, left-hand side, I'm left with 2x minus 3 to the 3rd power is equal to e to the 6th power. How do I undo the cubed? I can take the cubed root, and that's the same as multiplying that expression to the 1/3 power. So 1/3, 1/3, okay? So I get 2x minus 3. 1/3 times 3 is 1, so that's what I'm left with. And I get e to the 6 over 3 is 2. So I get e squared. Now I don't have to worry about plus or minus, because when I take cubed roots of something, there's only one potential outcome. I don't have the ability to have both positive and negative as my inputs. All right, so I am still trying to find the value of x. I have to add 3 to both sides and then divide by 2, and I will get x equals e squared plus 3, all of that entire quantity divided by 2. All right, try F yourself. Welcome back. I'm going to get rid of this natural log by raising that entire left-hand side, e to that power, and on the right, e to that power. I have on the left-hand side, I now have x minus 4 squared is equal to e to the 10th. I'm going to take the square root of both sides. You can think of it that way. And on the left-hand side, I get x minus 4 is equal to, and on the right-hand side, how do I take the square root of e to the 10th? Well, that's the same as taking e to the 10th to the 1/2 power. And so now we have e to the 5th. This is a even root, and so I have to be careful because I have both an option to have a positive or a negative number as an input that would satisfy that. So I have plus or minus e to the 5th. I will have x is equal to plus or minus e to the 5th plus 4, and that is my answer. G. All right, I'm still trying to solve for x. I have e raised to the 2x plus 3 equals 4. How do I undo e? I take the natural log of both sides, And now I will have 2x plus 3 equals the natural log of 4. I then subtract 3, 2x equals ln of 4 minus 3. I then divide by 2. X is equal to ln of 4 minus 3, all divided by 2. Make sure that division symbol is very clear what you're dividing by. H is your turn. Welcome back. How do I undo a natural log? Well, I raise e to that power. I'm going to raise both sides of that equation. So on the left-hand side, I get 5x is equal to e to the 4th. Okay, how do I undo I have x as a denominator. I want to get it by itself. So I'm going to move it over by multiplying both sides by x. When I do that, I get 5 equals e to the 4th times x. Now I'm going to divide both sides. Okay, sorry, I got interrupted. Now how do I get x by itself? I need to divide both sides by e to the 4th, and I get x is equal to 5 divided by e to the 4th, and that is my answer. All right, that concludes my lesson for today. I hope that makes sense. Hopefully it's somewhat of a review, as it is very similar, if not identical, to the material that we've had before, except now it is with natural logs. So again, reach out to me if you have any questions.